Good wishes. Today we are going to see about Karnaugh map. In that we are going to see 2, 3, 4 variables. Before that, we should know sum of products of sum, standard SOP forms, and how we can convert the normal SOP into a standard SOP, and what is the min terms and max terms. A Boolean function is an expression that is formed with the binary variables and two binary operators. The binary operators have been combined with the help of or and not operators. Examples: f equal to x, y, z dash. So in that, the given function is represented in the form of table and a logic circuit. So to implement the Boolean function with the less number of gates, we should minimize the literals and the number of terms. So the terms can be represented in the two forms, that is SOP and POS. So SOP is known as disjunctive normal form. A product term is any group of literals that are AND together is called a sum of product. The best example for the sum of product is the given function f equal to a comma b comma c equal to abc plus a into b dash into c dash. So in that abc is a one product term, and another one is the a b dash c dash is another product term. So we have combined these two terms with the help of r. So it is called as sum of product. Again, we can represent the sum of product in the table form. So the given function f equal to a dash b dash c plus a b dash c dash plus a b dash c. So the given terms is represented as 1. So the unknown terms are represented as 0. So in that way, we can create a table. So next one is the product of sum. The sum term is defined as literals or a sum of literals. So these terms are arranged in the product of sum form. That means the product of sum is groups of sum terms, and the sum terms are connected together with the help of AND. So example of product of sum is the given function f is equal to a dash plus b into b dash b plus c dash. Here a dash plus b is a one sum term, b plus c dash is another sum term. So these two terms are connected together with the help of AND. So this will be called, this is the best example of product of sum. So we can say the product of sum as conjunctive normal form. So again, the sum of product of sum can be represented as a table format. So we can have a 3 literals. So we can create a table with the combination of 8 combinations. With the help of 8 combinations, we can make the table. So the given function is a plus b plus c into a plus b dash plus c dash, a dash plus b dash plus c. So the terms, the given terms, that is sum terms is represented as 0. So remaining terms represented as 1. Next one is the standard SOP and POS forms. That means the canonical forms. So these are the special cases of SOP and POS forms. So the canonical form is known as the standard forms. Here, the given function, may be some literals may be missed. So that terms will be called as a uncanonical form. So we should convert the uncanonical form into a standard and the canonical form. Then only we go for the remaining procedures. So canonical form, each individual term in the SOP is called a min term, and each individual term in POS is called a max term. That means that is the product term. We can simply say it as a product term is called a min term. Sum term is a max term. So we perform sum of min terms, also known as the sum of products. So we perform product of max term is a product of sum. So in the given example, or a given function is an uncanonical form. The given function f equal to ab plus abc dash. In that first term, ab is an uncanonical form because the given function is a combination of three literals, but first term have missed one literal. So it is an uncanonical form. So now we have to convert the uncanonical form into canonical form. For that, we should find what is the missing literal. So in the given expression or a function, the first term c was missed. So we have to or and we have to and the term c and c dash to that ab. Okay, so we can convert that uncanonical form into canonical form. So final expression of the canonical form is ab dash c plus abc plus a dash bc dash. So next one is the now we can easily convert the uncanonical form into the standard form. So next one is the POS, product of sum. So in the product of sum, so here we have the steps to convert the SOP into standard SOP. So first of all, we have to find the missing literal, and next step is and each product term having missing literals with the terms formed by adding the literal and its complement. So expand the term by applying the distributive law, and we have to reorder all the terms, all the literals in the product term. Then we have to reduce the repeated terms with the help of the law. For example, the given function is the AB plus BC plus AC. So in that, in each term, we have missed one literal. First term we have missed C, second term we have missed A, third term we have missed B. So that we have to and the term and plus its complement. The I have showed how we have to and that particular terms. So after that, we have to expand that in the given way, like ab dot c plus c dash here. So we have to expand like as per law, we have to expand abc plus abc dash. So finally, we have to omit the repeated terms. So in the same way, here we have to convert the non-canonical POS into standard POS. The same procedures, same steps to be followed for that. So first step is to find the missing literal in each term. After that, we have to or each sum term, we have to expand that. Then we can reduce the repeated product terms with the help of the law. So the given function f equal to a plus b into b plus c into a plus c. So in the each term we have missed one literal. So the first term c was missed, so we have to or that c and its complement, that is c dash. So we have to add the term a plus b plus c into c dash. So we have next step is we have to expand that. After expanding, we can reorder all the literals as per order. After that, the final step is the omit that repeated terms. So after removing, we have to remove all the repeated terms. We can finalize the function. So next one is the min terms. So min terms, we can already know that un terms are called as the min terms. So max term is called as the R terms, like x plus y. So x plus y or x plus y dash is the best example of max terms. So again, we can represent the min terms and max terms. If we have value ABC equal to 0, 0, 0 means we can represent that values as a min term A dash, B dash, C dash, and the same for the same value we can create a max term is A plus B plus C. So this is very, very important. We have to know that how we can create a min term and a max term. That means in a min term, when we create a min term, if we have a value 0, that is represented as a complement variable. And for a max term, if you have a 0, that should be taken as a normal variable. So this is very important. We have should noted. So based on this concept, we can create a min term and a max term for all the given values. So for example, the min terms given A dash, B dash, C dash plus A dash B C dash plus A dash B C plus ABC. So in that A dash B dash C dash is equal to M0. A dash B dash C. So we have to create the table. From the table we can represent the min term as M0 plus M2 plus M3 plus M7. So finally we can summarize that with the help of summation. Why we have used summation here means for the representing the min term we should use a summation. For representing max term, we should use a by. So summation m equal to 0, 2, 3, 7. So in this way, we can convert the given terms into the numbers. So next one is the max terms. The same way we can convert the terms into the values. For that, we should use pi for representing the max term. So next one is the Karnaugh map. So before going to Karnaugh map, we should know what is min term, what is max term, so what is sum of product and POS. So we should know how the functions was created. So these things are very important before going to start a Karnaugh map. So Karnaugh map is a, we can simply say it as a K map. So it is mainly used to simplify the Boolean functions with the help of Boolean postulates and theorems. So why we are going to Karnaugh map means because if we are using the given Boolean function and we are going to convert into that all with the help of we are going to convert into that logic diagram means we need more number of OR gates and AND gates. So it will take time consuming and we need more cost. We have to spend more cost creating for designing the logic circuit. So to reduce that limitations, we are going for a Karnaugh map. So K map is used to help to simplify the Boolean function. If you are reducing the Boolean function, we can easily design the logic circuit. So K map is introduced, first of all, it is introduced by the Wedge and modified by the Karnaugh. So it is known as the Wedge diagram or Karnaugh map. So it is a graphical method which consists of 2 power n cells or n variables. We can say the Karnaugh map or a K map. So K map is mainly used to simplify the Boolean function. If we simplify Boolean function, we can design the logic circuit in a simple way. So constructing K maps to 2 to 4 variables. So here the K map contain boxes called squares. So each of the cell represents one of the 2 power n possible products formed from the n variables. So if we have a n variables, we can have a 2 power n cells. So in the case of SOP, how we can simplify the expression? So two methods to represent the Boolean expression. So this is the one method for a 2, 3, 4 variables. So I have represents the one variable also. If we have a one variable a means, so we can create 2 power 1 equal to 2 cells. So two cells we can create. So one cell is used to represent a dash, another cell is used to represent a. So next one is the two variables. Two variable means 2 power n. That means 2 power 2 equal to 4 cells. So we can create 4 cells for two variables. The 4 cells are used to represent first cell first cells are represented by A dash B dash. So A dash B is represented in another cell. A into B dash represented in third cell. The finally A B have represented. Again, in the same way, three variables and four variables cells are created. For a three variables, we can create a 2 power 3 equal to 8 cells. So we can create 8 cells in a horizontal manner as well as vertical manner. Or vertical manner. If we have a four variables, we can create a 16 variables, 16 cells. Method 2. So in this method, we can represent each cells in the form of terms. So second method, we can represent the variables like M0, M1, M2, M3. So in the same way, we can represent one variable, two variable, three variable, and four variables. So first of all, how we have to represent in a K map? We should know that. So the given expression is y equal to a b c dash plus a b c plus a dash b dash c. So the given terms are represented as one. Another another cells are represented as 0. After representation, we go for a grouping. So grouping cells or the grouping technique is used to simplify the Boolean expression. So grouping means combining terms in a adjacent cells. So we can group in case of one cell or two cells or four cells or 8 cells or 16 cells. So we can group a corner cells or a top and bottom cells. We can group it. So I have shown how what kind of cells we can group it. So here we can group the adjacent cells like the corner cells we can group or we can group in a floating manner. If we have first row and last row having one means we can group the first row and the last row. Totally we have 8 cells. We can group 8 cells in a one group. So these are some examples for pairing the cells. So what kind of way we can group and what should not done, what should not do. So all are represented in the diagram. So pair of ones are horizontally adjacent or vertically adjacent. So whatever way we can group the adjacent cells. So grouping should be done in single ones or two ones or four ones or 8 ones or 16 ones. So these are the ways we have to group it. Okay, thank you.